Hi all, good to broadcast to you today. We're going to look at carboxylic acids and all you need to know for the GCSE. Now this used to be something associated with the A-level specification, but it now can be found on the GCSE. It's pretty straightforward, okay? So far that we know that alcohols have the functional group OH and alkenes have the functional group C double bonded to another C. Carboxylic acids are chemicals with a functional group COOH. Okay, now something you need to remember when you're drawing the carboxylic acid is that the carbon is double bonded to the oxygen, which means in terms of covalent bonding that there are two electrons from each that are shared together. So let's have a look at methanoic acid or methanoic acid. So you draw two carbons, okay, in the chain. This is the functional group here. So the C double bonded to the O and the O and the H. You can draw them diagonally from that as well. So we've got one carbon in the chain connected to that functional group, which what makes it methanoic acid. If you remember with the alkanes, you had methane, ethane, propane and butane. Here you've got methanoic acid, ethanoic acid, propanoic acid and butanoic acid. Just showing you the first two. So this has got one that's connected to the functional group. This has got two carbons that's connected to the functional group. So when you're going up the scale, so for example, when you're doing propanoic acid, then you would do C3H7COOH. Okay, because they are acids, they behave like acids. Okay, something to remember: ethanoic acid is diluted, vinegar is diluted ethanoic acid. So these are weak acids, and your definition of a weak acid is a weak acid only partially ionizes in an aqueous solution. Okay, so with acid behaviours, they dissolve in water to form an acidic solution with less than pH 7. They react with metals to form a salt and hydrogen. They react with bases. Remember, a base is something with a pH above 7. So therefore you could think of it as an alkali. It does not always dissolve in water because it's a base. They react with bases to form salt and water. And last of all, they react with carbonates to form salt, water and carbon dioxide, which is something you will have looked at earlier in the specification when discussing acids. The one thing that stands out for me on the carboxylic acid part of the specification is you need to know one example of esterification, and there's only one esterification thing they can ask you. This is when you combine an alcohol with a carboxylic acid. Okay, this is the one example you need to know. You don't need to know any others. So if we take ethanol and combine that with ethanoic acid, okay, what happens is that we get a bond form across here and the water forms a separate chemical here. Okay, so here we've got the hydrogen from the ethanol, the hydrogen and the oxygen from ethanoic acid. That shifts out of the way. Okay, so we've got water, leaving you with the remaining elements in a branch. You need to know that this ester, and an ester is a chemical that is nice smelling, okay, and there are other things you need to know to make it an ester, but that's just a simplification. The ester is known as ethyl ethanoate, and if I read it to you from the specification, students do not need to know the names of esters other than ethyl ethanoate. Thanks, AQA. So that's esterification. Ethanol plus ethanoic acid. The water comes out of that in condensation polymerization. Okay, so here you've got your water, and that leaves you with ethyl ethanoate. All the very best.